We have our next speaker. We have Nicholas Jamieson here. Hey, Nicholas.
Hi, Alex.
We cannot. Oh, yeah. Now we can hear you. Nicholas is a freelance front-end developer, RxJS core team, and he'll be talking about improving the developer experience with RxJS tools. All right, let me add Nicholas's presentation here. Here you go. You're presenting. Thank you so much, Nicholas. Go ahead.
Great. Thanks, Alex. My talk is an updated version of a talk that I gave last year at RxJS Live. So I've made a few changes to the tools. At that stage, they were a work in progress. I was hoping to have a beta out fairly soon after that talk, but I've done a whole bunch of other work on them. So this talk is an updated version of that talk, as well as an explanation as to why you are still waiting for these tools. So we'll start with a quote, and the quote is that some people have said that RxJS is impossible to debug. So only some people, everybody else just says that it's really hard to debug. I don't disagree with this. I would just qualify it. I would say that RxJS is really hard to debug with conventional debugging tools. And thinking about this problem, RxJS isn't alone in being difficult to debug with conventional tools. There's a whole bunch of other stuff that's also difficult to debug. I mean, CSS, you can't debug CSS with a debugger. React components and Angular templates, if you declare something and it doesn't work, a debugger isn't always the best tool to figure out what's going on with that. And ESLint rules, if you're writing an ESLint rule, ESLint rules use selectors to match AST nodes, and those selectors are very much like CSS selectors. And again, a debugger is not a very useful tool for figuring out why your ESLint rule isn't working. So looking at these things, there is something that all of these things have in common. I mean, they're all declarative. CSS is declarative. The rules in ESLint, the matches that are used for those, they're declarative. Your React component, your Angular template, these things are declarative. So we have specialized tools for dealing with CSS. We use the Chrome dev tools to look at how our rules are working, to look at how they're being applied, to look at what's overriding what. We use the React dev tools to figure out how our components are working. Basically, we need to step away from the debugger and use something else. So thinking about this, do we need a different tool to work with RxJS? If we have a look at a snippet of RxJS code, we've got a form here in Angular, values changes. We're going to pluck a term out. We're going to debounce it, and only take the distinct changes. So it's obvious from looking at this that RxJS is a declarative thing. We're just declaring the behaviors that we want and applying those to an observable, which are the form changes. And if it doesn't work, the usual advice is, do something like this. You'll put a whole bunch of taps in, you'll log stuff to the console, and then look at what's happening with those logs and deduce what's happening with your program. So when I started working with tooling to make developing with RxJS a little bit better, a few years ago, I wrote a tool called RxJS Spy. And the very first thing that I wanted to do with that tool was remove the need to have to modify your code to put in this sort of logging. So the way that tool works, at the core of it, is it has this tag operator. So you can take a tag operator from RxJS Spy, you can compose it into your observable, give it a name, that is the tag, and then you can work with it using the tool by annotating your observables and your pipelines with tags. So the tool is something that you would incorporate into your application. So you would import RxJS Spy, you would set it up, and RxJS Spy would expose an object on window called Spy, and you would interact with the tool using the console. So you would have your app in the browser, you would open up the dev tools, you go to the console, and you could type in. So you would communicate it with RxJS Spy using the command line. You could type in RxJS spy.show, hit enter, and it would give you a bunch of information about all of the subscriptions that it had seen. So it would tell you how many subscriptions you've got, the tags to which they're subscribed, the value counts, the number of values that have gone through those subscriptions. It'll give you the stack frame so you could sort of poke around and have a look at it. So it's a whole bunch of stuff that's more easily available, and you could sort of poke around with it and you can see more of what's happening in your application. You could also switch on logging. So once you've got things that are tagged in your application, you can go to the console and switch on logging. You don't have to manipulate your code. You can switch on the logging for people and it will tag the notifications, log the notifications as they're happening. And there's a mechanism there where you can undo the thing. So you can switch logging on and off on a tag basis. The other thing you could do with it is you could pause observables. So with a tagged observable called people, you could call pause. It would give you a deck. Using that deck, you could step over a notification. You could skip notifications and you could resume. So it'll just play the notifications that have been paused. So this stuff was pretty useful. You could inspect the observables that were in your application. You could interact with them. And the show gave you some degree of visualization, but not a great deal because it's pretty much a command line tool. So there are things that could be improved with it. So I did start thinking about the way that we could write a better set of tools for RxJS, ideally so that we didn't have to use a tag operator. So we didn't have to make any changes to our code. Also, so that we didn't have to include RxJS Spy or something equivalent to it in our app. So rather than sort of importing something in our app, it would be nice to not have to do anything like that. And something where we could actually visualize what was happening with subscriptions. It should also be discoverable because being a command, essentially a command line tool, RxJS Spy was pretty constrained in terms of figuring out how it worked. You'd have to know what commands you were going to run. You'd have to go to the console. You'd have to type it in. It was not the most straightforward thing to use. So what I wanted to do was write a dev tool, something that integrated with the Chrome or Firefox or Edge dev tools, gave you a panel in the dev tool in which it would display all of the information about RxJS subscriptions in your app. Now, the way dev tools work, this is just a high level sort of overview of what happens, is you have a dev tool in the panel, which is a JavaScript application. When you load your app, your app will be loaded into a tab. The dev tool is going to load a content script into that tab. So this is a completely separate JavaScript context inside the tab. It's outside of your application. It can manipulate the DOM. And what happens is it manipulates the DOM and essentially injects a script into your app. So the parts that you see highlighted here are all contained in the dev tools, the Chrome extension, which integrates with the dev tools. So we've got the panel, content script, and the tools. So the tools are injected into your application. You don't have to have any dependency on the RxJS tools to use them in your app. All you need to do is call patch. So the way that the tools get hooked up to your application looks a little bit like this. So this snippet of code is going to look for a particular symbol on window, which will be, that'll be the symbol that's been added to the window for the injected tools. And that symbol has as its value a patch function. So if you call patch and pass in the targets, which are the observable and the subject from your RxJS library, it will wire up your application to the tools. So that's it. There is no dependency in this case. You're just going to run, call patch if it's there. If it's not there, the tools aren't installed. Call patch, pass in the subject, and then your app is wired up to the tools. There is a small package which basically just wraps up those few lines. So you can import that rather than having to sniff out the symbol yourself and just call patch. And because the RxJS tools package is being bundled using the same bundler that's packaging up your application, it's going to have the same RxJS package that you're consuming. So in this case, you don't need to pass in the target. It's really straightforward. You just import patch, call patch if you want to wire up the tools, and away you go. So in terms of what the tools look like, this is the panel that would be shown in the dev tools. It's depending upon how you've arranged your windows, it's either split vertically or horizontally. So on the left, we've got subscriptions. And on the right-hand side, we've just got an info pane selected at the moment. So if we highlight one of these subscriptions on the left, we'll get the information about it. So the subscriptions that are on the left form a tree. We can expand them. The icons borrow from the marble syntax. So a line with a circle on it means it's emitted at least one value. So we can see the fork join at the top hasn't emitted anything. The switch map underneath it has emitted at least one. We can see in the switch map that we've expanded it. We can see that there are 3 maps inside it. If you look carefully, you'll see those map icons have a dashed outline indicating that those are inner subscriptions. And below that, there's a tag, which has a solid outline, so it's the source. So we can, just looking at the iconography, we can get some information about what's actually happening with these subscriptions. We can see that 2 of the inners have been unsubscribed and 1 of them is still subscribed. So the information on the right-hand side gives us the same sort of information in text format. We can see that there's 1 open inner subscription. There are 2 closed inner subscriptions. We can see the first and the last values that were emitted from the switch map. You can see when they occurred, and we can see when the subscribe occurred. So pretty useful. We can get a good overview of what's actually happening in the application. We can focus on particular subscriptions, and it's far more visual than the command line interface that we had for RxJS Spy. So the other thing you can see is that each of these subscriptions that's shown on the left-hand side has on its right a small circle with a chevron on it. So what those are, if we expand that open, we've got a bunch of commands that we can use to switch on logging for each subscription. We can take a snapshot of each subscription. If we click on the snapshot's value, we can see all of the values, all of the attributes that are accumulated for that snapshot by the tooling. Tagging is still available, so you can give a name to a subscription. The tag operator still works if you want to keep using the tag operator. It's possible to pause subscriptions, so we can do the same sort of pause that we did with RxJS Spy, and you can step over things. And then you can resume. Now, the other thing that is shown in the logging tab are warnings. So in this case, we've got a zip operator. Zip is going to take values from multiple sources and emit them combined, but it waits for each source to emit before it emits the combination. So if you have a slow source and a fast source, you have a potential buffering problem where you go to an open-ended buffer and you're going to be accumulating values from the fast source at a greater rate than the slow source. And it's useful to find those situations, and the tools will warn you about those. So they'll give you a warning for buffering and for a bunch of other different things. And those warnings show up in the log panel as yellow. So you can click on those and you'll see it'll highlight the subscription that has the problem, and it'll expand the tree. And the highlighting and the expansion works using the search bar. So if you look up the top, you'll see that it's got buffer count is greater than or equal to 100. So that's the limit, the default limit for the warning for buffer counts. So this is using the search functionality to link the warning to the zip subscription that's in the tree. So you can use the search functionality in a manual way as well. So we can type in a bunch of things. We can type in things like operator names, and we can select the operator. We can type in the source names like a subject. We can also type in the IDs. Internally, IDs are used for observables and subscriptions, so you can search based on ID. You can also search based on files, so you could search for subscriptions that are made to observables that are in a particular file. Now, these searches are just JavaScript expressions, so we can combine them. You can search for things that are in a particular file that are complete or incomplete, or we can search using any of the other attributes that are collected in the snapshot. So value counts, whether thing's hot, whether it's cold. It's really quite powerful in terms of what we can do with this sort of searching functionality. So the tools have several advantages over RxJS Spy. There's no dependencies at all. There's no overhead. So you could leave the patching switched on in production if you wanted, and you could use the tools to debug and inspect production applications. We've got a visual representation of the pipelines. We've got discoverable features. We can see everything in the user interface. So we can see our subscriptions. We can highlight a subscription. We can open the button, open the command panel that lets us log and snapshot and pause and do all that sort of stuff. And we've got queries. So we can do fairly powerful queries in terms of finding observables based upon subscriptions, based upon their properties, their names, their states, the number of values they've emitted, the types of values. Pretty useful stuff. So in terms of what I've been doing with the tools for the last year or so, since I gave this talk in Vegas last year at RxJS Live, the user interface has changed completely. I've made it a great deal simpler. The tools that I showed last year didn't have integrated logging. The logging was logged to the console. So you would have to split the dev tool. You'd have the console underneath. You'd have the dev tool at the top, and you would get more conventional logging with the console. The logging is now integrated, so we can log a history of notifications. We can switch them on and off and we don't lose them. That's as you would if you cleared the console. But the most sort of wide-reaching change that I made in the last 6 months has been performance-based. The original version of the tools took RxJS Spy, and RxJS Spy is the backend for RxJS Spy is essentially what's injected into your application by the tools. So when you load your application in a browser that has the tools installed, the dev tools loads the content script, and the content script injects the tools into your application. Initially, that blob of JavaScript that was injected into the application was essentially RxJS Spy. Now, there were performance issues when you ran it with either an application that had a large number of observables or an application that had observables that emitted at a very high frequency. So with RxJS Spy, the snapshotting was done essentially on demand. So when you went to the console and you typed in spy.show, it would take a snapshot and it would show you the contents of the snapshot in the console. So the initial version of the RxJS tools used that mechanism and took snapshots when things changed, and then pushed that snapshot through to the developer tools and would show you the information in a tree. Now, there was just too much information that needed to be moved every time a snapshot was taken. So one of the things that's changed is that it no longer works that way. The backend, what I call the backend, the injected tools now send only what's changed when notifications and subscriptions and those sorts of things occur in the application. So it's much more performant. There's a lot less information that needs to travel back and forth. But to make that change involved refactoring pretty much everything that was in RxJS Spy. The last thing that I've been working on has been making the configuration of the tools as straightforward as possible. So what I wanted to do is have the ability to just switch these things on and off very easily using Angular. And it was really quite timely that I listened to Fabrice's talk today, because one of the things that will be happening is that for the Angular configuration, it'll be entirely based on schematics. So you'll have a schematic that lets you switch on the RxJS tools, and when they're switched on, that'll be it. You don't need to change anything else in your application. There'll be no code changes whatsoever. So have a quick look at how that actually works. When you're compiling TypeScript into JavaScript, your TypeScript runs through the compiler and then it outputs JavaScript. One of the things that you can do with the TypeScript compiler is you can use a transformer. And what that lets you do is, in your transformer, you can manipulate the AST to change the output of the compiler. So down the bottom, you can see the output's changed. We'll just focus on what those changes are. So this is what would ordinarily be output from the TypeScript snippet that we had in the previous slide. So what the transformer does is it adds an import, which imports a development file from RxJS tools transformer. And what that will do is it will patch your application into the tools if it hasn't already been patched. The second thing it does is it wraps sources and subscriptions and operators in small functions that add some context and also capture the names of what you've got in your program. So those functions get added down the bottom of the file. You can see they capture whether or not it's a core source, whether it's a core operator, the name, the temperature, that sort of stuff. And those functions are basically just going to call lower level functions that tag some information onto the observable using a symbol. So the main reason for doing this isn't just convenience. The thing is with RxJS is that there's a whole bunch of operators. So in RxJS Spy and in earlier versions of the tools, what used to happen is it would interrogate the observable, the subscriber, that represented an operator. So in RxJS, in the core, the map operator has its own map subscriber, and that map subscriber is a class, and that class is named map subscriber. So RxJS Spy and the tools would try to figure out the name of the operator based upon the name of the subscriber. So with map subscriber, it's fairly straightforward. You just take subscriber off the end. It's called map. So, you know, it was the map operator. So you can represent that in the tree and it sort of all makes sense. The problem is that using that technique gives you some very strange names. You might be looking at an observable, composed observable, and you might be quite surprised to find that instead of the switch map, instead of the start with that's in your code, it shows up in the tool as merge map. It seems really bizarre, but start with is implemented with concat map, and concat map is implemented with merge map. So the whole thing gets really strange. So being able to use a transformer to capture the actual name means that you get the correct names for the RxJS operators. It also means you get the correct names for any user operators and any user observables. It also captures the context, captures the function in which it's called. So when you are querying it, you can query it on the file that it's in. You can query the function that it's in. And the other thing that it lets us do is using a transformer, we can not only just add information to instrument and to capture the context and the names for the application, we can also remove information. So the transformer, when it's running in dev mode, it will add these functions and it will capture the names and capture the context so that you get an accurate representation of your observable, your composed observable in the tools. But when you're running it in production mode, it doesn't do that. But not only will it not do that, it will also remove any tag operators. So using tag operators is still useful because you can give your parts of your application very specific names. So instead of having to say search, you know, I'm building up a query where you're searching for something that's in a particular file and a particular operator that's in that particular file or a particular observable that's in that file, you could search for a tag. So you can give something a name that makes perfect sense for your context, for your application's domain. And you can use those tags to work with the tools, knowing that when you do a production build, those tags will be removed. So you'll have no performance overhead whatsoever. So that's what I've been working on. The tools this time are very close to being in a beta. There's a URL that's there. If you go to that page, there's a mailing list. One of the things I'm going to start doing soon is sending out a newsletter detailing where the tools are at, how the progress is going, and also how you can use the tools to solve particular problems. So that's my talk. Hopefully you've got some questions for me, and I hope this has been useful.
Thank you so much, Nicholas. Yeah, I've been very excited, and I was very sad that I, will miss your talk from Las Vegas. It wasn't uploaded to the YouTube, so I've been bugging you about this for a long time. Thank you for actually doing the talk for us. I personally learned a lot from you, and yeah, I'm very excited and happy to have you at AngularToronto. so you can share the knowledge with everybody, all our attendees. Let's see if we have any questions for Nicholas. Yeah, mind blown. Yeah, I kind of agree. Now, first question is, so first question is, can we have this yesterday? Yes, it's probably a lot of work, and
yeah, well, most of the big parts are done. There have been other things that have pushed me off track lately, as you could sort of understand. But the refactor was the big one, changing it so that it just worked. The main reason I didn't want to release it is because I had hoped that it wasn't going to be such a performance issue, and that it would work with just injecting the SPI into the application, and that things could be refactored and redone at a later date. But it really was quite crippling when you put it into a large NGRX application and that sort of stuff. The amount of information that needs to move back and forth across the communication channel, because when the app communicates with the dev tools, it has to package up the entire snapshot as JSON. Each of those things that you see, in fact, there's another one as well, because there's a background script. So your app goes to the content script, then it goes to the background script, then it goes to the panel. And each of those is a step through a different JavaScript realm, and shoving this huge amount of JSON around each time was just not going to work. And that JSON in the SPI, you can see, and when SPI outputs stuff to the console, it includes the stack frames. So that blob of snapshots that went across this communication sort of pathway each time included the stack frames, which included the files. So it was really big. So rather than sort of just try to get it working by cutting down the volume, I decided it made proper sense to actually refactor it and do it properly, so that information is only sent across when things actually change or when it's requested. So the queries both ways when you are looking at the snapshot. So when you log something to a snapshot and it goes into the log window, and then you click on that and it shows you all of the information in the tools, that's actually a query back into your application, which gets that information for tools and then returns it back to the SPI. So yeah, it was just not going to work very well for people if it wasn't performant, and if it's so slow and so clunky, it was just not going to happen. And the other thing was that the name issue was something that was very confusing as well. So I think to release something that was slow and didn't really work that well and had very confusing names because you lost your custom operators, and because things like start with had really bizarre mappings to merge map, it was really quite strange. I mean, it confused me looking at the tree of subscriptions that didn't sort of make any sense, and seeing merge map there and then looking at your code and there's no merge map in your code. It was baffling. So most of the hard work's done. I just need to tweak the colors a little bit and see how we go in terms of getting it accepted into the Chrome App Store. But if you do have a look at that link and subscribe to the mailing list, before it's actually publicly available, I'll be doing a beta, and the beta will be invitation. So if I've got your email on the mailing list, there'll be another email that goes out. And if you confirm that you actually do want to use the tools, then I'll make it available to you via your email.
Nice. Yes.
Not yesterday, but soon.
Yeah, I'll definitely want to try it. There's a related question to the topic that we're touching on right now. Is it going to be open source?
It's not open source at the moment. I have to think about exactly how much of it I will open source.
Sounds good. Because, for example, if we would want to use it, some of the corporate environments, they block the extensions, right? That are just downloaded from externally. For example, the same practice goes within Google, and some of the things for us to use it for that code, same as, for example, Redux DevTools, we had to basically build it our own, basically get the code, build our own, and push into the local internal Chrome extension store. So we can, because that one basically is code is analyzed and made sure that there's nothing Of course, there would be nothing, but it's just, depending on the APIs that the extension requests. Nice. Okay, so let's see what other questions we have. Can you see? Can you manage spot debug memory leaks or unwanted subscriptions when you have multiple subscriptions from the same observable through the tool?
Yeah, you can just you can run queries that will tell you the number of subscriptions that you have to a particular observable. You can run queries that will tell you based upon the age of the subscription. You can combine them, so you can have queries that are based upon the age of the subscription, the number of times that subscription is actually emitted values. One of the things that I will be working on is just building up a predefined list of useful queries, so that you don't have to type these things every time, so that you can have a query which is, find me style subscriptions, that sort of stuff. But yeah, it's quite powerful in terms of what you can do once you build up a query using a few of these attributes that have been collected in the snapshot.
Nice. Let's see if we have any other questions. I don't see any. I'm very excited about this extension. I mean, this is something for me. Tab console log is like a very frequent thing that I have to do, especially since if it's in Jirax, it's at least we have Redux DevTools that show all the actions and stuff. But for example, something with a component store that we are having right now, which is a smaller thing that it doesn't connect to any Redux DevTools. Something like RxJS DevTools would be really awesome because it would be mostly wiring that all up. And unless otherwise it's just pausing and their breakpoints and maybe trying to get into it. But then again, if there's no bodies of functions, right? You can't really even debug it with the breakpoints. You have to refactor some of the things. So yeah, I think it'll be a fantastic thing. Thank you so much for presenting it.